Myself Mohammad OS Khan of CSC ANML is here to give a presentation, and my topic is polarizability, polarization vector, electric susceptibility and displacement vector. Polarizability. Polarizability usually refers to a tendency of matter when subjected to an electric field to acquire an electric dipole moment in proportion to that applied field. It is It is a property of all matter, in, in as much as matter is made up of the elementary particles which have an electric charge, namely protons and electrons. Here you can see the polarizability of chlorine and chlorine and aluminum. Polarization vector. The total dipole moment per unit volume is called polarization, since it is more precisely a polarization vector because inside the unit volume many dipoles are present with the dipole moment which itself is a vector from a negative charge to a positive charge. Now what will be the direction of polarization? It fully depends on the external field applied and whether the molecule is polar or non-polar. Polarization is the dipole moment per unit volume, since it is more precisely a polarization vector because inside the unit volume many dipoles are present with dipole moment which itself is a vector. Electric susceptibility. The ratio of magnetization in the substance to the corresponding magnetization force is called the susceptibility or the magnetic susceptibility, whereas the ratio of electric polarization to the electric intensity is polarized dielectric or also known as electric susceptibility. The formula is M is equals to phi into H, where M is the magnetization of a solid, X is the the formula is M is equals to X into H, where M is the magnetization of a solid, X is the magnetic susceptibility of the substance, and H is the magnetic field. Displacement vector. The change in the position vector of an object is known as the displacement vector. The change in the position vector of an object is known as the displacement vector. Suppose an object is at a point A at time 0 and at point B at time is equals to t, then the position vector of the object at point A and B are given as position vector at a point A is equals to RA vector, which is equals to phi I vector plus 3j vector plus 4k vector, whereas position vector at point B is equals to position B vector is equals to 2i vector plus 2j vector plus 1k vector. Now the displacement vector of the object from time interval 0 to t will be RB vector minus RB vector is equals to minus 3 vector minus j vector will be RB vector minus RB vector RA vector 1 minus RB vector is equals to minus 3 vector minus j vector and minus 3k vector. RA vector minus RB vector is equals to minus 3i vector minus j vector minus 3k vector. The displacement of an object can also be defined as the vector distance between the initial point and the final point. Suppose an object travels from point A to point B in the path shown in the back, back curve, the displacement of the particle would be in the vector line AB. Headed in the direction from A to B, the direction of the displacement is always headed from the initial point to the final point. Fun fact, displacement can displacement can also be as the shortest distance between 2 points. Thank you. This is the end of my PPT.